everyone, this is Morgan. So we're going to be talking about writing chemical equations today, page 3 of the reactions outline for honors. And often what will happen is you'll be presented with a sentence written out that describes a reaction. And we have to be able to translate that into a balanced chemical equation. Okay? So the first thing is you need to know your nomenclature. Did I mention you need to know your polyatomic ions? Because you'll be using those all the time. Now, the next thing that comes up often is, what's the state of matter going to be for a species if you're not told? Most of the time you're going to be told. But what if you're not? How do you know when something is a gas? Gases are everything that's molecular. Okay, so when we're talking about the things that we called Hofbrinkel, if something is made up of two nonmetals together, it is most likely going to be a gas. Liquids. Liquids are trickier. These are actually the hardest to know, which is why we almost always will describe something as a pure liquid in the sentence. Now, aqueous means a solution. And solutions are always described as solutions. In our situation, they're going to be dissolved in water. There are other different solvents that can be used, but we don't deal with them at this level. Okay? Aqueous coming from the root aqua, meaning water. Now, solids. The things that are automatically going to be solids are metals and ionic compounds, which means we have a metal with a nonmetal. Now, important, we often just refer to these as salts. Okay? So let's remember now that the abbreviation for gases is G. Often people like to put it in parentheses. Liquid, we like capital L. Aqueous, AQ, lowercase. Solids, S. All right, so let's look at some examples of that now. Solid sulfur plus oxygen gas yields sulfur dioxide gas. So solid sulfur would be capital S with a little s after it plus O2 gas to give you SO2 gas. Now, relatively straightforward because each of the states of matter has been identified for us. That's nice. The formulas are pretty straightforward, simple formulas. Now, the next one. Solid carbon reacts with oxygen gas to make carbon dioxide gas. Well, carbon, solid, plus O2 gas to give me CO2 gas. Now, something that can be a little tricky in here for those of you who make the connection. Carbon has different what we call allotropes. It exists in different forms. It can be graphite, like what's in your pencil. It can be diamond, okay? It can be a big soccer ball shaped C60 molecule that's called a fullerene. So sometimes we might say that in this description, but not for what we're doing. Pretty much carbon with the S is good for solid carbon. Sodium metal, since it's a metal, it's a solid, reacts with chlorine gas to make sodium chloride solid. So sodium metal is Na with the S plus Cl2 gas. We have to remember Hofbrinkel, all of these diatomics when they're alone, to yield NaCl solid. To balance that, we put a 2 there and we put a 2 there. Okay. Calcium carbonate is heated to form carbon dioxide and calcium oxide. So CaCO3. Now, since that's ionic, that's going to be a solid. When we heat it, we get carbon dioxide, CO2, which is a gas. We know that to be a gas because it's molecular. Okay, two nonmetals together. Calcium oxide, CaO, would be a solid because it is ionic. Okay. Methane gas, CH4, and you'll notice often we give you the formula if it's a more complex thing that you might not be familiar with, is burned in oxygen gas, O2 gas, produce carbon dioxide, CO2, which is a gas, and water. Now, since I have the word water vapor, I know that water is going to be a gas and not a liquid. To balance this, I put a 2 there, and I put a 2 there. All right, we're going to practice that in the homework. We'll be doing this the entire year, actually. Chemical equations are important to everything we do. All right, thanks for tuning in. This is Morgan signing off.